Alright, so we just tried one example of a rational inequality. We're going to go ahead and try our second example now. Now that you've seen one, kind of a little bit of an idea of what to do. So I'm going to go ahead and show you another one now that's a little bit different, but it does go along with the first problem that you'll see on the back of your homework. So if you get stuck on that one and you need something to reference, go ahead and look back at this video. So for this one, here's what we're going to try. 4 divided by x minus 3 is greater than 3 divided by x plus 2. Okay, now there's a little bit more algebra for us on this one that's going to be involved at the beginning. But you'll actually see that this one, when we start doing the little number line, it's actually going to be a little bit easier. So, as I stated on the last problem, one of the first things you need to look for is you need to make sure the right side is equal to 0. Which in this case it is not. So if we want to make the right side equal to 0, our very first step would be to subtract that 3 over x plus 2 from both sides of the equation. Okay, now when we get here, what we'll see is two fractions, okay, but they do not have common denominators. And in order to add or subtract fractions, you must have common denominators. So for us on this one, common denominator is going to be pretty easy. It is simply x minus 3 times x plus 2. Okay, so what we're going to want to do is we're going to want to make sure that both of these fractions have that common denominator. And here's how we can do that. Okay, here's what we've got on the first fraction. But the other thing that it needs is it needs an x plus 2. So what I'm going to do is I'm going to multiply in an x plus 2 on the bottom, which means I got to do the same thing to the top. Because if I mess with the bottom of a fraction, I got to mess with the top as well. Because when I do that, all I'm really doing is multiplying the fraction by x plus 2 divided by x plus 2, which is just 1. And we can multiply anything by 1 if we want to, because that doesn't change it at all. Okay, so now we're going to do something similar with the second fraction. So we've got that for the first fraction. The second fraction looks like 3 divided by x plus 2, but what it's missing is an x minus 3. Okay, so what we're going to go ahead and do on this one is we're going to multiply an x minus 3 on the bottom. And if we do that on the bottom, we're going to do the same thing up on the top. Okay, and once again, all I did was multiply by a fancy form of 1 x minus 3 divided by x minus 3. Okay, now these fractions have the same denominator. So what I can now do is I can put both of them on the same fraction. Okay, and I can combine it all. So here's what I've got. I'm going to go ahead and distribute here as I go. So 4 times x is 4x. 4 times 2, positive 8. Please keep in mind that this sign in the middle of these two fractions is a minus. So when I distribute this 3, I really need to distribute a negative 3. So what we're going to get here is negative 3 times x, which is negative 3x, and then negative 3 times negative 3 gives me a positive 9. Okay. When I look at the resulting fraction, okay, I'm going to keep the denominator the same as I have been. But up on the top there are some like terms that I need to combine. So 4x minus 3x gives me a 1x, and then 8 plus 9 is 17. So when I'm done with this step, here's what I've got. X plus 17 divided by x minus 3 times x plus 2. So now we can come over here and we can figure out what are we looking for. We're looking for the zeros from the top, which for us is going to be x equals negative 17. And then from the bottom, the undefines. Okay, and the undefines for us are going to be x equals 3 and x equals negative 2. Okay, and remember those are undefined because we cannot divide by 0. So if I tried to plug in those x values, what they would make me do is they would create a 0 on the bottom, and it would make the entire expression undefined, hence the name undefined. So after this, it's all the same as the previous problem. Okay, but notice we don't have as many numbers to test this time, because last time we had 2 zeros and 2 undefined. This time we only have 1 0 and 2 undefined. So we're going to go ahead and put these on the number line. We've got negative 17, negative 2, and 3, and we'll pick some numbers to test. So let's try, let's go negative 18 over here. Okay, we'll try negative 3 right here. We'll try 0 right here, and then we'll try 4 on the right side. Okay, and just like last time, we're going to plug into the factored form at the end, and we're going to use that to help figure out if our final answer is positive or negative. So let's try negative 18 first. Negative 18 plus 17 is a negative number. Negative 18 minus 3 is negative, and negative 18 plus 2 is also negative. So when we're done, we have a negative divided by a negative times a negative, which is a positive. So a negative divided by a positive results in a negative answer for us. Okay. Alright, let's try negative 3. Negative 3 plus 17, we've got positive. Once again, I won't say this out loud for all of them. We'll have a positive divided by negative times a negative. Positive divided by a negative is a positive. Okay, if we plug in 0, we get a positive divided by a negative times a positive. That will give us a positive divided by a negative, which is a negative. And for 4, we'll get a positive divided by a positive times a positive. So positive divided by a positive, which will also result in a positive. Okay. So we've done our number line. Now we need to think about what kind of numbers do we care about. In this case, when we were done, we were looking for numbers that were greater than 0, which means positive numbers. So for us, that would give us numbers right here and right here. Okay. So these all have open circles on this one. And we are looking for numbers that fall in this interval and then fall in this interval, going all the way off to infinity on the right. So if we were putting that in interval notation, what we would have is negative 17 to negative 2, parentheses, union, and then we go from 3 all the way up to infinity as we go all the way off to the right. Both of those are going to have parentheses as well because we are not including. Okay. So big thing on this one is we got to get one side equal to 0, and then if we have two fractions, we got to find a common denominator if we want to add or subtract those fractions together. Okay. I will come back and I will show you the third example here in my next video.